applied load. Space is not allowed while labeling anything. Okay? Yes, space is not applied load. Just capitalize the word. I capitalize the L of load. You can read it easily. Applied load. L is highlighting it. So in displacement form, okay, not in load form. So select the surface and apply the load. You can see the z-axis, the vertical axis here. So you will apply in z, which is 50 millimeter, because it is displacement. You can see a displacement. So 50 millimeter is applied load on the top. Means the sample will be compressed when completed job. It will be compressed up to 50 millimeters. Displacements and forces are connected with a stiffness matrix F. F is equal to Ku. That is the equation of stiffness method in structural engineering subject. Stiffness method. F is equal. F means force is equal to K multiplied by U. Displacement and forces are directly proportional to each other with involvement of K. K is a stiffness matrix. It will calculate the stiffness matrix by itself. If we give U, it will automatically convert it to force. If we give force, it will automatically convert to U, displacement. So we have given U, it will automatically convert into force. Though it does not matter for this. I have to edit negative direction. So I have to change its direction. So if you want to edit anything, just use these bars, these materials. Okay. I want to edit apply load. So double click on it. Which is very angry man. No, no, not just we can open by clicking, by double clicking on it. Oh, why not clicking? Okay, let's click here.
Directly applies.
No, it will. So where is the mouse? Click it. Connect the mouse.
Like this.
Okay, edit it. Add it. Give the minus direction because minus. Because the z-axis is positive upward and downward will be minus, so we have to apply downward minus load. Okay, change the direction. Now we have to come to mesh next stage. In meshing, of course, here the first instance, the part, and that is the maximum 400 height and 200 diameter. A small mesh will be okay, that's like 15 millimeter. 15 millimeter pieces because 400 millimeter is over a height of the column. So apply it. Okay, 1500 millimeter mesh is ready. Not showing why. What is the RAM of this computer? 16, and why it is working a little bit slow? So here has been. So first click on this instance the part. Define, give it the how much the size of each part should be. I have left 50 millimeter. Then click on this meshing. Mesh, select it and OK it. It will be meshed. So click it here after instancing. It has been meshed. Now next part is optimization. I think there is no need for optimization. It's very simple. Of course, it will give the error of missing property. We have not defined any property here. So next is job. Job here to create the job first. Okay, job has been created. Just simplify it. No modification here. If you want to submit the job here, submit. Here, submit the job. If we submit, it will give the error there. Monitor it. Monitor it. It will give the error there. No property for any material. No. Define the properties. Error is just coming here. So here is the error. 5103 elements have missing property definitions. It means there are total 5103 elements.
Yes.
Parts, smaller parts, dual machine. all have missing property. We have not defined the second section. We skipped at this stage. So that is your first column. It is ready and it is not taking a job because we have to work on this property. We work on this property in the next. Initially, you can define it just. If we have to define, just click here. Material one, that is material one is concrete. Name is concrete only. Give the mechanical properties, elastic behavior. Elastic behavior. Young's modulus. Concrete have maybe young modulus of 50 gigapascals. Uh, 50, 1, 2, 3, 50 gigapascal in Newton per millimeter square. 50,000 megapascal. You know, megapascal is equal to Newton per millimeter square.
Yes.
Megapascal is equal to Newton per millimeter square. So our unit is consistent with megapascal. So concrete normally has the elastic modulus of 50,000 megapascal, and steel has 200,000 megapascal. Means 200 gigapascal steel and 50 gigapascal for concrete. So we have given it 50 gigapascal, means 50,000 megapascal. And Poisson ratio for concrete is mostly 0.2. Okay. If we give the Young's modulus and Poisson ratio, it defines the stiffness of a stress strain curve. It defines what is the uh, it defines if the stress strain curve for concrete here. Here is strain, here is stress. It defines what is the increasing line and straight region up to how much. That defines elastic modulus. And Poisson ratio means how much deformation occurs in two directions. Means laterally how much expansion in lateral direction to the how much expansion in longitudinal direction. That is Poisson ratio. Means after application of load, how much expansion occurs, how much change shape occurs with respect to time. Similarly, you give the other mechanical property, plastic behavior, where is the ultimate point that is called Fc prime, strength of concrete. Give here, yield stress. Assume it is 30 megapascal concrete, and you know megapascal is equal to Newton per millimeter square. That is our consistent unit. So we give 30 simply because 30 Newton per millimeter square or 30 megapascal, same consistent unit. Plastic strain is 0, 0. Concrete has no plastic strain, just like upward it only falls. It does not show like this steel, no.
Yes.
I will give you another table, an Excel sheet, a whole Excel sheet in which all these parameters will be calculated. You just give the input later on to refine the property. Because I am just assuming them and giving them. No, there will be no error for property. Okay, okay, okay. No, we have just defined the material. We have not assigned to it. I have just created here the material you can see here. Here is only concrete material generated. Now we have to create the sections. Section one means column. That the column section, maybe other section, maybe steel tube section. If you have more than one part, then this is a column section that will be solid, homogeneous. Okay, if it's steel tube, then you select shell elements. Column, just only one material was created. It has already been selected. If there are more than one material, then there will be options. Okay, okay, make it okay. Now assign it, give it. Click on here, assign section. Select here, assign. Color will be changed. Okay, it is column section done. Property has been assigned. We have told Abaqus that it is concrete by giving the properties of concrete. Now submit it again. Replace the previous job. Okay. Now it will run and give the results. In the next class, I will tell you about the history output. how to obtain the required outputs. Stress strain, maybe load deflection curves, how to obtain it by using history outputs. Now you will not get any results. You will just view the deformed shape. To obtain the results, we have to create set. We have to define the set to the history outputs and then plot the results. That I will tell you in the next class.
Sir,
In the meanwhile, you view the videos from YouTube as well. Increase your grip, increase your knowledge.
okay, sir, अभी दो वीडियो हैं स्टडी टाइम भी ना
वहीं पे काम करते रहें वीडियो देखें फ्री जब भी
वीडियो
होते
जरा
हैं
देखते रहेंगे इसको
इंक्रीज योर इंटरेस्ट यू वांट पब्लिकेशन अगर पब्लिकेशन नहीं करनी वो भी आपकी मर्जी में आपको फोर्स नहीं कर रहा
नो सर वो इंशाल्लाह
हाँ
प्लीज
करनी है गुड आप एजुकेशन रखें आप चलते रहें साथ साथ नॉलेज इंक्रीज होगा इस टॉपिक पे फिर आप राइटिंग पे नॉलेज चले आप भी चलेगा वरना नहीं चलेगा No, there will be status completed. No, it is 0.83% completed. No, completed is one. It will be completed as soon. Yes, completed. Cross it. Now you can monitor the results of results. You can just click on results. Here is just click on the deformed shape. Here is this. This is a deformed shape of column. You can view the video as well. Play here like this.
एनिमेशन
Yes, animation. Bottom is fixed. It is here fixed.
Yes, sir.
We have applied load on top side. It is just compressing it. And what is the load? Again, deformation. Load is increasing and deformation of occurring. Where is the curve? I will tell you in the next class.
Okay, sir.
This is
So for me,
part up now. Enough. Here is off. So your save is Control S. Give name as P01. Model P01. You can save it to any place if you want to
no,
save
there you can select.
You can save it.
It's locked.
इसको सेव करें यहाँ पे भी इसका नाम P01 है इसकी दो फाइलें इंपॉर्टेंट होती हैं जो कि आपको डिलीट नहीं करनी होती मॉडल को बचाने के लिए एक है CAE फाइल लिख लें CAE फाइल क्योंकि बहुत सारी फाइल इसने जो अभी जनरेट की होंगी इस मॉडल ने अगर किसी को मॉडल शेयर भी करना हो तो एक CAE फाइल है और एक फाइल है JNL जर्नल फाइल JNL फाइल और CAE फाइल ये दो फाइल डायरेक्टरी में से आप कॉपी करके उसको देंगे बहुत सारी फाइल ये बनाएगा लेकिन आपके लिए ये दो फाइलें इंपॉर्टेंट होंगी इसी तरह ODB फाइल है जो कि आउटपुट डाटा के लिए अगर किसी को देनी